In this video, we are going to continue our discussion of identities and taking trig expressions and simplifying them by focusing on factoring for a moment. We have two main types of factoring that you guys have studied in Pre-Calc 1 or Algebra 2 or College Algebra. We have factoring by the GCF, or we have factoring by factoring a quadratic. If you need help with factoring quadratics, please email me, and I will see that you get a link from me that teaches a great way to factor a quadratic. All right, or maybe you just need to review. I can send you a smaller video maybe of some practice, maybe even the way that you have learned it if you tell me that. Okay, so problem example 3a. This is factoring by the greatest common factor. So this factors, notice that both terms has an a squared. So I factor out an a squared, and now what I need is I need two numbers that go here and here that are going to multiply by a squared to get me back to my original expression. So a squared times what gets me an a squared? Well, that's going to be a 1. A squared times what is a squared times b? Well, that would just be a b. So we're going to use this in a moment to simplify some expressions. Okay, the other way of factoring is to factor this by having two sets of parentheses that FOIL or multiply distribute out to get me back to the original expression. Okay, what that's going to be is I have an x and x out front. Those would multiply to get my x squared. I have a 1 and 1, and the only way those are going to in the middle, my inside and outside, to add to -2, we'd be that those both be -1. And then we also could take this one step further. We could say x minus 1 squared. All right, if you need help with that, and that's like a very basic one, if that was kind of iffy for you, you may need to email me, or you can Google factoring quadratics and find some help that way. Please just get some help with that topic. All right, take a look at example 4. Notice that example 4, we have this two terms. And the first thing I'm always looking for is I'm always looking for a GCF, always. Right, so notice that both of those have a cosecant squared term. Notice I'm writing theta. We have to every time. You cannot leave that blank. If you do, you will miss points. Okay, we have cosecant squared theta times something in both of these parts that is supposed to get me back to this expression here that we started with. So cosecant times what is cosecant theta? Well, that's this multiplication right here. That's going to be a 1. Then we also have cosecant times what will get me back to cosine squared, cosecant squared. Well, that would just be a cosine squared. So notice if I multiply that back through, I get back to the original expression. All right, let me pull this down off here. So you can see now if you multiply those two, you can get back to our original. All right, so now I'm going to leave the cosecant alone. And we can see 1 minus cosine squared. Okay, well, that's just sine squared by our Pythagorean identity. Right, and then I'm trying to make a 1. Okay, cosecant squared is actually 1 over sine squared theta. Remember, we're writing our theta every time, times sine squared theta, and that's really over 1, which is going to make a sine squared over sine squared, which is 1. Notice I'm showing all my steps. I didn't put sine squared over sine squared because that's a pretty trivial step. You can't just not write anything, right? Oh, I see that it's equal to 1 because you didn't actually show me. So make sure when you're verifying identities, you are showing, for you guys, I would show every little step for a while. And then you'll start learning which steps that you don't really need to show because they become easier and easier that happen every time. All right, take a look at example 5. We're going to work through 4 problems here. Or 3, forgive me. Counting's hard. Okay, take a look here. This is a FOIL problem we're distributing. So this is our first term times our first term. Our first time terms times our last term. And then the insides, and then the last terms. I can do them in any order I want. So sine times sine is sine squared theta. Right? And then we have, I'm going to do the outsides. Sine times cosine is sine theta, cosine theta. Then the insides are going to be negative sine theta, cosine theta. And then the last ones are negative cosine squared theta. Okay, I want to put an equal sign because that's equal. Notice that these two terms are going to cancel out, leaving me with sine squared theta minus cosine squared theta. Now, as much as you mess with this, this will never turn into sine squared plus cosine squared. We can't use that Pythagorean identity that we used to begin with. But what I can do is, and I have two routes. One route I'm going to take will be, I'm going to replace my cosine squared with the identity that changes it to sine. So this becomes sine squared theta minus, and I'm going to replace, now we've got to put it in parentheses because I've got to minus all of it, 1 minus sine squared theta. All I did was replace this cosine squared with that identity there. Okay, this turns into, we're going to get 2 sine squared theta, right? Because this negative goes to both, so it makes a positive. And then I'm going to have a minus 1. Okay, I also could have taken a different route. I want to highlight these two different routes so we know we went two different ways. That's one answer. Or I could have replaced the sine squared. So this could be 1 minus cosine squared theta minus cosine squared theta. What I did there was I replaced sine squared theta with 1 minus cosine squared theta. All right, so I just took the other out, and then this is going to be 1 minus 2 cosine squared theta. We're going to work with these quite a bit here in another couple sections, but we have that this has two answers. Okay, so this is equal to this, 2 sine squared theta minus 1. Notice I'm putting my thetas everywhere. Don't forget that. And that's the same as 1 minus 2 cosine squared thetas. So all three of those are equal. We'll use those formulas here in a couple sections. All right, problem B. So problem B, it's tempting just to square tangent and square 1 and call it good, but this actually means tangent theta, notice I'm writing my theta, plus 1 times tangent theta plus 1. All right, this just becomes a FOIL like we just did in that last problem first. So tangent squared theta, outside plus tangent, inside we get another plus tangent, and then last would be a plus 1. So this is equal to tangent squared theta plus 2 tangent theta plus 1. I'm going to move these over because I want the space there for problem C. So that's multiplying that out. Make sure you're not, the big mistake that happens there is people just square it, both tangent and 1, and call it tangent squared plus 1 and call it good. That's not how that works. Okay, here, this is a hidden quadratic. So it's actually the same if it bothers you having the signs. We're going to call them u's. So I'm going to let u equal sine theta. So that means I have u squared minus 2u plus 1. And now I'm just going to use u. You could have used x if you wanted to, if that's more comfortable. So I replaced them. And now this is that factoring that we talked about at the beginning. This is, I think, the exact same problem. We have u minus 1 times u minus 1. If you need help, you got to reach out to me. I have some videos that'll clear that up. It'll take work. It'll take some reps, but I can fix your factoring. Okay, and then u minus 1 times u minus 1 is u minus 1 squared. And then we can replace u with sine theta. Make sure you're writing your theta. You'll miss it if you don't. Minus 1 squared. All right, so these are going to take some practice. You'll get faster at this whole factoring thing if you put some time into it, and then this stuff will get quicker too, but you'll need to be able to do this, the squaring and all that stuff, and replacing your cosine squareds and your sine squareds. All right.